For most of the students, the thought of exams gives them an adrenaline rush in their body. The moment these students step inside the examination hall, they go there with much expectations. And if those exams are your first board exams, then the expectations are higher. But what happens if the schedule of your exams gets broken in between? Yes, I am talking about this year's ICSE exams. All of us know our entire country is in a state of lockdown due to the ongoing coronavirus. Due to this, all the remaining ICSE exams were terminated in between. None of us know when the remaining exams will be rescheduled or in which month. Perhaps these students are spending the most difficult time of their life right now. Now, those who have already chosen their subjects or streams for class 11, a hearty welcome to all of them. Now, being a physics teacher, today I thought of sharing with you the syllabus of physics for class 11. Now, I don't know whether this is the right time or not, but I thought this might give a joy to their faces and create a little bit of excitement for the upcoming year. Hello students, my name is Sonic. So today I shall discuss with you the ISC physics syllabus, question pattern and the marking scheme for class 11. Make sure you watch the video till the end. So let's begin. First, let me tell you what are the parts of the physics exam. The physics exam will be taken in two parts. The first part will be the theory portion. It will be out of 70 marks and the students will get a time duration of 3 hours. The second portion of the exam is the practical part. Now the practical marks will be 30. The students have to give a practical exam out of 30 marks and the time duration for the practical exam will be 3 hours. So as you can see, the total marks is 100. The chapters which are there in class 11 physics. Now for the first unit, it is physical world and measurement. Now in physical world and measurement, the first chapter is physical world and measurement. Now in this physical world and measurement, you are going to learn about what is physics, what are the different branches of physics, who were the great scientists who laid their impact in this world, what are the applications of physics in this world, and much more. The second chapter is units, significant figures and error analysis. Now in units you are going to learn about the fundamental units and derived units. In significant figures, I hope all of you know about significant figures, so I am not going into that part. Error analysis. Now this is a new thing which you will learn in class 11. Now what is actually error analysis? Now you know all of us make some errors while calculating something, while experimenting something. Now it is very important for you to identify those errors and calculate them. Unless you calculate the errors, you will not understand whether you can take the observed value of your calculation or not. So in this chapter, error analysis, you are going to learn about the different types of errors, how to eliminate those errors and how to calculate those errors. Okay, so let's move on to the second part. Unit 2 deals with kinematics. Now in kinematics, the first chapter is motion in a straight line. Now this chapter is not new to you. If you remember your physics syllabus of class 9, you will remember there was a chapter in physics, motion in a straight line. So this chapter, motion in a straight line, is quite similar to that chapter. Some parts over here are new, but some parts in this chapter are new, but almost the entire chapter is same as what you have already read in class 9. The next part is motion in a plane. Now this chapter is very, very important. Motion in a plane. Why it is so important? Over here you are going to learn about vectors. Now vectors is such a chapter which you will require throughout class 11 and class 12, almost in all the chapters. It's a very, very important chapter. I hope all of you have some concept of vectors. Scalars and vectors, I hope all of you know, or all of you have little concept about vectors. But over here you are going to learn vectors in details. So make sure when your teacher is going to teach you this chapter, vectors, don't miss that class. Next we have projectile motion. Now this is also a very important chapter. I don't know whether you know projectile motion or you have any idea of projectile motion or not. Suppose if I throw a stone, how does the stone goes? The stone takes a parabolic path. Now that is a projectile motion. Now suppose if I give you a stone and if I tell you that you throw the stone in such a way so that it makes a maximum horizontal range, that means it goes to a maximum distance, and if I ask you that at what angle you are going to throw the stone, any answers? This one we will find out in this chapter, projectile motion. The chapter deals with lots of informative things like if you throw any body in a projectile motion, what will be the maximum height or what will be the horizontal range or how much time the particle or the body will take to fall down in any position if you throw that body or that particle in projectile motion. So this is a very interesting chapter, so make sure you don't miss out this chapter. Let's go to the next part. The next part is laws of motion. Over here the first chapter is Newton's laws of motion. I hope all of you have read about Newton's laws of motion. It was there in class 9. Now over here also most of the chapter is same as what you have already read in class 9. Only some parts of the chapter there are few numericals and some applications are there which are new to you. Next, friction. Now all of you know what is friction. All of you have a basic idea of friction. In this chapter you are going to learn about how to calculate friction or what are the types of friction that are acting on a body. How to identify those friction and how to calculate those friction. Over here also you are going to learn about when any body is moving, taking into account the friction, what will be the resultant motion of the body. Next chapter is uniform circular motion. Now, this is also a very interesting chapter, uniform circular motion. Now uniform circular motion, you read a little bit portion of this in class 10. There was a part in class 10 of uniform circular motion. Now over here uniform circular motion deals with the rest of the chapter which was not there in class 10. There are many interesting things which we learn in this chapter, uniform circular motion. Suppose for example, have you seen in a bike race when the biker takes a turn, he leans towards the road. I hope all of you have seen this one. Now why does the biker leans towards the road? The answer you will get in this chapter, uniform circular motion. Or have you seen if you take a bucket and if you tie it in a rope and if you rotate the bucket in a vertical circle, now when the bucket is at the topmost position and if the bucket containing the water is upside down and you are rotating the bucket at the topmost position when the bucket is upside down, still the water will not fall from the bucket. Why does that happen? You will read in this chapter, uniform circular motion. The next part is unit 4, work, power and energy. Now this part also you have read in class 10. But over here, what is the difference? The derivations and the calculations you will do over here in class 11 are a bit different than you have done in class 10. You have to do the derivations and the calculations using a different branch known as calculus. The next part is unit 5. Now this unit is also very interesting. The first chapter over here is the center of mass. Now you have read about center of gravity. Now center of gravity and center of mass is more or less quite similar. Now, over center of mass you will read about what is the motion of a system of bodies. The next part is rotational motion of a rigid body, moment of inertia. This chapter is also very important, moment of inertia. Now over here what you are going to learn? You are going to learn about the rotational motion. That means when a body rotates. So this was about circular motion, this is rotational motion. So when a body rotates, what are the different equations of motions over there? The next part is gravitation. Now this is the most important chapter, or you can say this chapter while teaching, I like this chapter the best. This is the best chapter according to me in the entire syllabus, you can say. Now in this chapter you are going to learn lots of things. What are the things? You are going to learn about the law of gravitation. You are going to learn about how the acceleration due to gravity depends when you go up from the surface of the earth or when you go down the surface of the earth, and various other factors taken into account. You will learn about the different laws of planetary motion. You will learn about Kepler's laws. You can understand all these terms are quite new to you, but you can trust me, this chapter is very, very interesting. There are lots of interesting things which you are going to learn in this chapter. You are going to learn about escape velocity, you are going to learn about different types of satellites, you are going to learn about how the satellites move, how many types of satellites, and much, much more. Let's come to the next unit. Unit 7, Properties of Matter. Now this branch is also known as General Properties of Matter. Now what are the chapters over here? The first chapter is Elasticity. Now elasticity is a particular property of any matter. Now what is actually elasticity, or how do you calculate the elasticity of any matter? All these things you have to see over here in this chapter. Now, do you know whether a steel is more elastic or a rubber? How to prove this one? So all these things you have to learn in this chapter, elasticity. It's a very interesting chapter. If you go through it properly, I hope all of you will understand. The next chapter is fluid pressure. Now this is a chapter which is very similar to the chapter you have learned in class 9. One of the chapters of this one you have learned in class 9. What about this chapter? Pascal's law. Yes, I am talking about Pascal's law. Now this chapter, fluid pressure, all the portions over here are more or less same to that chapter which you read in class 9, Pascal's law. In this chapter you will get the hydraulic principle, Pascal's law, and the different apparatus or the different machines which are based on Pascal's law. This is a very easy chapter. I don't think you will find any difficulty in going through this chapter. The next chapter is Flow of Liquids, Viscosity. This is yet another very, very important chapter, viscosity. Now viscosity, in normal words if I try to explain you, it is actually liquid friction. Now when a liquid moves, there is a friction acting between the layers of liquids. Now this chapter you did not read anywhere in your lower classes. This is a complete new chapter for you, viscosity. It's also a very interesting chapter. Now there are very, very important things and very interesting things which you will learn in this chapter. Like terminal velocity. Do you know why an ant doesn't die when it falls from a particular height? Do you know what is terminal velocity? Or do you know what happens in the swing of a cricket ball, or how does a cricket ball swings? So all these things you will learn in this chapter. Have you seen when we water our garden with a hose pipe? I hope all of you have seen a hose pipe or a normal pipe. So when we water our garden with a normal pipe, sometimes to increase the speed of the water, we press the mouth of that pipe. Now why do we do this one? Now this fact is totally based on a principle known as the principle of continuity. So what is that? You are going to learn this chapter. Next you will learn about Bernoulli's theorem, which is yet another very, very important theorem for you to understand. How does an aeroplane fly? So you can understand this chapter is very interesting. If you go through this chapter properly, you will find it very, very interesting to read and to do the derivations as well. The next chapter is surface tension. Now what is surface tension? Now surface tension is a property of a liquid by which the liquid tends to acquire a minimum surface area. Okay, now this one I am not explaining everything over here right now. Now I told you just in a single line. So this is actually surface tension. Here also you are going to go through some derivations and some theories. Have you seen some insects walking on the surface of water? So that actually is happening due to the phenomenon of surface tension. Or have you seen if you blow a soap bubble, it tends to acquire a spherical shape. Why does it happen? Due to surface tension. Or if I ask you a question, do you know why do we use soap water to wash our clothes instead of plain water? Now some of you can say that soap water cleans the cloth nicely instead of plain water. But if I ask you why the soap water cleans the cloth nicely or cleans the cloth better than normal water? Okay, so all these things you will learn about in this chapter, in surface tension. Now there is a particular difference between viscosity and surface tension. Viscosity is such a property of a liquid which deals with liquid in motion. That means when the liquid is flowing. So that time we use this viscosity. Okay, and what is surface tension? Surface tension is the property of a liquid when the liquid is at rest. Okay, now one more thing we learn in surface tension is that, have you seen when you insert a capillary tube in a liquid, a normal capillary tube, if you insert in a liquid, the liquid automatically rises up in the tube. Why does this happen? Or if I ask you the equations or how it is occurring, so all these things we learn about in surface tension. Okay, so this part will be easy for you. This is not a very tough part. If you go through the derivations and the numericals properly, I hope this will not create a difficulty. Properties of matter. Okay, let's come to this next part. Unit 8, Heat and Thermodynamics. Now, in this chapter, this unit is maybe it is completely unknown to you, but don't get afraid, it is not tough. It is unknown, but it is not tough. Let's see what are the chapters over here. The first chapter is thermal expansion calorimetry. Now calorimetry already you have read in class 10. So if you know calorimetry properly, this chapter will not be a problem for you. Now besides calorimetry, what are the things that you are going to learn over here? The main thing that you are going to learn over here is thermal expansion. Now I hope all of you know what is thermal expansion. That is when you supply heat to any body, the body expands. That is thermal expansion. The body, I can say, it can be solids, it can be liquids, it can be gases. Okay. Now when the body is expanding, there are certain factors which you need to keep in mind. That means how much heat we should supply to the body. Okay. And in that much heat, how much the body is expanding. Okay. So all these things we are going to learn about in calorimetry. There are few numericals and a few derivations. The derivations are not very long. So if you go through it properly, it will not be a problem for you. Next chapter is heat transfer. I hope all of you are familiar with the words conduction, convection and radiation. Okay, yes, I know. So this chapter, heat transfer, deals with these three words: conduction, convection and radiation. Okay, now in conduction you will find there are 2 to 3 derivations which are unknown to you, which will be new to you, but those are not difficult. If you practice it 5-6 times, you will be able to do those. So conduction, I hope you know. Convection is a very small portion over here. Convection, I hope all of you know convection. But the most important part in this chapter is this one. Radiation. Sorry, it's not written. Radiation. Now radiation, in lower classes, the term radiation was already there. But over there, only the definition and only a few portions of radiations were there. Only the easy ones. Only the concept of radiation was given to you. Over here in class 11, you will learn radiation in details. Okay, so what is radiation? I hope all of you know. Now, what are the things that you will learn over here? What is a perfectly black body? How radiations occur? Okay, what is Stefan's law? What is Newton's law of cooling? So all these things you are going to learn over here in this portion, radiation. Okay, so when you are reading this portion, remember that this portion, radiation, is very, very important. Okay, most of the questions are from radiation and your conduction. Conduction is also very easy. I said there are 2-3 derivations. If you practice it again and again, you will be able to learn this one. But radiation needs some concept to understand. So let's come to the next review. Okay, the next chapter is thermodynamics, first law. Now, this is also a very new chapter to you. Thermodynamics, first law. Now, if you have not heard the word thermodynamics, it's not a problem. The thermodynamics is a special branch of physics which deals with, you can say, when heat transfer takes place between two bodies, it deals with the reason why the heat transfer is taking place, or you can say what happens to the initial and final states of the two bodies. Okay, that means when the heat transfer takes place, what happens to the initial and the final states of the two bodies. So that portion is your thermodynamics. Now thermodynamics has 2 laws. In this chapter we are going to learn about first law. Now first law is very, very easy. What is actually first law? I hope all of you have heard law of conservation of energy. Now this law of conservation of energy is actually the first law of thermodynamics. Okay, now feeling confused? No problem, you will learn in this chapter, first law of thermodynamics. It's a very easy chapter. The second portion is, the next chapter is isothermal and adiabatic process. Now this chapter is also very important, this chapter. Make sure you don't miss out this chapter, isothermal and adiabatic process. Because if you miss out this chapter, isothermal and adiabatic process, you will not be able to do the next chapter and the next chapter. So this chapter has a direct link with the second law of thermodynamics and behavior of perfect gases and kinetic theory of gases. Okay. Now what is isothermal and adiabatic process? If I want to tell you in single sentence, isothermal process. Now what is actually isothermal process? If you see a system, okay, and suppose a system, what is a system? Suppose in normal words, if you see a container, the container is containing some gas, suppose. And suppose the gas is expanding or the gas is contracting, that means the system is undergoing some change. Okay. Now when the system is undergoing some change, if the temperature of the system does not change, that time it is known as an isothermal change. Okay. And what is adiabatic change? Adiabatic change means when a system undergoes some change, then if no heat is taken out from the system or it is absorbed by the system, okay, let me tell you again, if no heat is taken out from the system or no heat is absorbed by the system, that time that change is known as an adiabatic change. Okay. Now this chapter not only deals with these two, but there are lots of other things which you have to learn over here. There are lots of other equations, there are lots of very important derivations which you have to learn in this chapter. The next chapter is heat engine, second law of thermodynamics. Now I said thermodynamics has two laws, the first law and the second law. First law already it was here, this was second law. Okay, now before you are starting second law of thermodynamics, make sure, I am saying once again, make sure you are well versed with this chapter, isothermal and adiabatic process. You know everything in detail about this chapter. Okay, now in second law of thermodynamics, this chapter, it entirely depends on only one thing, that is Carnot's heat engine. Okay, now I cannot tell you what is Carnot's heat engine in such a less time. It's a very big concept and it's a theorem given by Carnot, also known as the Carnot's theorem. Now based on Carnot's heat engine, there are various appliances which we use in our day-to-day life. For example, the refrigerator. So how does a refrigerator works? You will learn in this chapter. Or what is the difference between a refrigerator and an air conditioner? Okay, so this is also a very important chapter and a very interesting chapter also, the second law of thermodynamics. Okay, so this was all about unit 8, heat and thermodynamics. Let's come to the next unit. Now the next unit contains a single chapter, that is behavior of perfect gas and kinetic theory of gases. Now this chapter, I will not say it's a short chapter. This is it's a big chapter, but it's a very important chapter. Now over here you are going to learn about very important and crucial things, that how does gases behave. I hope all of you are familiar with the word kinetic theory of gases. You know, when the gas molecules are in motion, if there is a gas and when the gas molecules are in motion, okay, so that time how does the gas molecule moves? Okay, so or what are the theorems or what are the theories behind those? So all these things we are going to learn about in kinetic theory of gases. You will also learn about the specific heat capacities. There are two specific heat capacities of gases. So all these things you are going to see over here, kinetic theory of gases. There are few derivations and few sums. In this chapter the numericals are very important. Most of the questions are based on the numericals from this chapter. Okay, so make sure you solve all the numericals properly. So this was about unit 9. So let's come to the last unit, unit 10, oscillations and waves. Now this portion is also a new portion for you, oscillations and waves. Now over here, let's see what are the things that you are going to learn. The first chapter itself is very important, simple harmonic motion. Now I hope all of you are familiar with the word periodic motion and oscillatory motion. Yes, now in class 7 and 8, you know, there were some questions like state the different types of motions, or there were some examples and you were asked to find out whether, that means you were asked to find out those set of examples belonged to which type of motion. Over there I hope you read about this periodic motion and oscillatory motion. Now there is a slight difference between periodic motion and oscillatory motion. I am not going into that one. Okay. Now simple harmonic motion, you can say in one word, if I want you to tell, simple harmonic motion is a special type of oscillatory motion. Okay. Now you know what is an oscillatory motion? When a body oscillates. So simple harmonic motion is not the same as oscillatory motion, but it is a special type of oscillatory motion. When a body is subjected to certain rules, that time we can say the body is executing an SHA. Okay, simple harmonic motion, that means SHA. Okay, that means if I ask you, suppose a spring, a body is suspended from a spring, and if you pull down the body, what happens? The body oscillates. Okay, now if I ask you to find out that whether this body is executing an SHM or not, how you are going to find out that one? Okay, so all these things we are going to learn about in this chapter. This is a very important chapter. Suppose a simple pendulum is there and the pendulum is oscillating. If I ask you to find out whether the pendulum is executing in simple harmonic motion or not, so that one also you will learn in this chapter, simple harmonic motion. So when the teacher is teaching you, don't miss out this chapter, simple harmonic motion is very important. All the numericals are very important, and there are some few derivations, those are also very important. Okay, and make sure you make the concept clear when you are reading this chapter. Now if you do not make the concept clear, what will happen? I will tell you. This simple harmonic motion has a direct connection with all these chapters, with the rest of the chapters. If you do not understand simple harmonic motion, it will be a problem for you. understanding all the rest of the chapters. Okay, so let's come to the next chapter. The next chapter is free damped and forced oscillation. Now this is the chapter, this is the only chapter over here which I think, and every year I have seen this one, it will be the easiest for you to understand. Free damped and forced vibration. Why? Because this chapter is exactly the same that you have read in class 10. Yes, it is exactly the same. There is nothing new in this chapter. All of you know what was free vibration. All of you know what was damped vibration, or what are the forces that are acting on a body when a body is in a damped vibration. All of you know what is resonance. Yes, I am talking about resonance, or the various experiments with resonance. So all these things you have read in class 10. Now the same things are again in this class 11. Now this is a very small chapter. Okay, free damped and forced vibration. Okay, it will take 1 or 2 days for you to understand this one, because already you read few months back in class 10 for ICSE. Let's come to the next chapter, waves. Now this chapter, waves. First you have to understand what are waves. Over here you have to understand what are waves. Okay, now this chapter, as I said, it is a direct connection of simple harmonic motion. If you do not understand simple harmonic motion, you are not going to understand this one. So what is actually a wave, or how a wave is generated? All these things we are going to learn about in this chapter, waves. This chapter it's not a very big chapter, it's a small chapter, but the derivations and the numericals in this chapter it's very important for you to understand. Most of the questions are from the numerical. It's numerical based question. Okay, from this chapter, waves. The next chapter is wave motion. Now, the wave motion has a direct connection with this chapter, wave. Now, if you understand wave, understanding wave motion will not be a problem for you. What is actually a wave motion? When a wave moves, how does the wave move? Or what are the equations? Or what is the velocity and what is the acceleration of the wave when the wave is moving? Or how much force is acting on the wave when the wave is in motion? Okay. Now, one more very interesting thing you will learn in this chapter is that all of us know the values of speed of sound in gases, solids and liquids. Now how those speed of sounds can be calculated theoretically. So that one you can understand in this chapter, wave motion. Okay, all of us know the speed of sound in air is approximately 332 meters per second. Okay, now the value is anywhere where you read this one, the value may be just written over there. The value of speed of sound in gas is 332 meters per second. But how you can calculate this one theoretically? This one was first tried by Newton. Okay, and afterwards Newton made a small mistake in calculating that one, and afterwards another scientist known as Laplace corrected that one, and he calculated the exact value of the speed of sound in gases. It's also a very, very interesting chapter. Or how does the speed of sound in gases change with the temperature, the humidity, okay, and there are many other factors. The next chapter is superposition of waves, interference and beats. This is also a very important chapter, and it will be a new chapter for you. Okay, now what is actually interference? When two waves meet, okay, if this is one wave and this is another wave. So if two waves meet, then what happens? There is a pattern, or there is a phenomenon known as interference. Okay, that phenomenon is known as interference. Okay, I am telling you just in a single line. Now this is an important chapter, and it's not a small chapter, interference. Okay, there are lots of equations and derivations which you have to do over here in interference. What is actually beats? You see the next portion, beats. Now beats is that whenever interference occurs, that means whenever two or more waves superimpose on one another, you will find that the resultant intensity of sound, sometimes it is going up and sometimes it is going down. That means the intensity of sound, sometimes it is becoming maximum and sometimes it is becoming minimum. Okay, that is known as the phenomenon of beats. Okay, now what are the equations over there, or how to solve all those numerical problems? Everything you are going to learn in this chapter, interference and beats. The next chapter is superposition of waves 2. This is actually the second part of this chapter, superposition. Stationary waves, vibration of air columns. Now see, what are actually stationary waves? Okay, now, if I go back to this chapter, waves and waves motion, these two chapters dealt with progressive waves. Progressive waves. Now what are actually progressive waves? progressive waves are the waves which moves. Okay, there is no definite boundary for the waves. It is moving continuously. Okay, from one portion to another portion, the wave is moving. That is a progressive wave. Over here, what you are going to learn? Stationary wave. What is stationary wave? Suppose when you blow air into a flute, how does the air column inside the flute vibrate? Okay, or suppose any particular air column has two fixed boundaries. So that time what happens? The air, you can say the air vibrates within the boundary. Okay, so what happens that time, or what are the equations of the wave at that time? So all these things we are going to learn over here. Stationary wave, vibration of air column. Fine. The next chapter is vibration of stretched strings. Now, how does a string vibrate? Fine. Once you understand this chapter, vibration of air columns, it will be very easy for you to understand this chapter, vibration of stretched string. The equations of motion are quite similar in these two chapters. Okay, so I think reading this chapter will not be a problem for you. Vibration of stretched string. If there is a string, if you pluck one end of the string, if you pluck any portion of the string, then you know the string vibrates. There are primary mode of vibration. There is first subsidiary. There is second subsidiary. I hope all of you are familiar with these words. First subsidiary, second subsidiary. So it was there in class 10. So all these things in details you are going to read over here. Okay, vibration of stretched string. There are 2 to 3 derivations which are very important, and few numericals are there. The last chapter is Doppler effect. Okay, so this is one more very interesting chapter, and it's a very important one, Doppler effect. Now, have you seen when you are standing on a platform and a train is approaching towards you, whistling? The train is continuously whistling and the train is approaching towards you. You will find out that the frequency of the whistle changes. Okay, the frequency of the whistle changes when the train is approaching towards you. Now, why does this happen? Okay, this happens due to a phenomenon known as the Doppler effect. Okay, or when the train is moving away from you and the train is whistling, again you will find that the frequency of the whistle, again it changes. Okay, why does this happen? This happens due to Doppler effect. This is a very small chapter. If you read it carefully and if the concept is clear, you can understand this chapter very clearly. It will not be a problem for you. Okay, most of the questions are based on numericals from this Doppler effect. So that was the end of all the chapters that you have in class 11 in physics. Okay, now let us come to the next part. So now I am going to tell you the mark distribution in your question paper. Okay, so this mark distribution had been set up by the council itself. So this is the mark distribution for the various units which will be followed in your question paper. Okay, now here you have the serial number. These are the different units which I told you about. These are the name of the units and these are the marks. Now see, physical world and measurement, kinematics and laws of motion. These 3 units, it will be based on 23 marks. Okay, so from these 3 units, you will get questions of 23 marks. Next, work energy power, motion of system of particles and rigid body, and gravitation. These 3 units will contain 17 marks. Okay, so this is 23, this is 17 marks. So 17 marks will be there from these 3 units. Properties of matter, heat and thermodynamics, behavior of perfect gases and kinetic theory of gases. These 3 units altogether will contain 20 marks. Okay, and the last unit that was there, oscillations and waves, there will be 10 marks from this unit. Okay, so 23 marks, 17 marks, 20 marks and 10 marks. So these are the marks distribution for the various units which you will read in physics. Okay, so 23 plus 17 plus 20 plus 10, it counts to 70 marks. So as I told you before, for theory, you have to write the theory out of 70 marks. Okay, so in 70 marks, these are the marks distribution. So let us come to the last portion and the most important portion, that is your question pattern. So what will be your question pattern? Now the entire question paper is divided into 4 sections, A, B, C, D. Okay, so there are 4 sections in your question paper. Now on top of the question paper, you will find a line, all questions are compulsory. Now this line might dishearten some of you. Now it has been 3 years since the ISC board have changed the pattern of the question paper. Earlier there used to be choices in the question paper, like 5 questions are given to you and you need to answer 4 out of them or 3 out of them, like you have done in ICSE. But from class 11 over here, all the questions will be compulsory. Okay. Now let us see what are the mark distribution in all the sections. So there are 4 sections, section A, B, C and D. Okay. Now in section A will consist of 12 questions. Okay. There will be 12 questions from section A, carry 1 mark each. Okay. So all the questions will carry 1 mark each. So all total there will be 12 marks. So 12 marks will be there for section A. 12 questions, 12 marks, 1 marks each. Okay. Now it has been seen generally that 5 questions, the beginning, the first 5 questions are generally MCQ. Okay, and the rest 7 questions are your normal questions. Okay, so the board is following this pattern since 3 years. The first 5 questions they give as the MCQ, and the next 7 questions they give like they are normal question answers. Okay, so they are very short questions. I don't think you will be having any problem answering them. So first section consists of 12 questions, 1 mark each, so 12 marks. The next section will consist of 2 marks each. All the questions will carry 2 marks. Okay, there will be 11 questions in total. That is question number 2 to question number 12. Okay, this was only question number 1. Fine. So this will be from question number 2 to question number 12. So you can understand there are 11 questions in total. All the questions will carry 2 marks each. Fine. So there will be 22 marks for this section B. Fine. Now there is one point over here. In these 11 questions, 2 questions will be having internal choice. Okay. Now what is the meaning of internal choice? Suppose for example, in question number 10, suppose question number 10 is having 2 subdivisions A and B. Okay, 2 questions are there in question number 10, A and B, and you are asked to answer either number A or number B. So that is an internal choice. So I hope all of you understood this one. So that is an internal choice. So 2 questions out of these 11 questions will be having internal choice. Okay, it is not like you have answered in your ICSE, like 11 questions are there and you need to answer only 10 or only 8 or 7. Okay, or 9 questions. It is not like that. Okay, all the questions are compulsory. Fine. And 2 questions will be having internal choice. So section B, 11 questions in total, 2 marks each. The questions will contain 2 marks each, so 22 marks in total. Section C. Section C all the questions will carry 3 marks each. Okay, and there will be 7 questions in total. Fine. So there will be 7 to 3, 21 marks for this section C. Now this is from question number 13 to question number 19. This was up to question number 12. So section C will start from question number 13 to question number 19. So 7 questions. Over here also 2 questions will be having internal choice. Fine. 2 questions you will find internal choice in these 2 questions. Okay. So 21 marks for section C. Let's come to the last section, section D. Fine. Now section D is a long answer type section. Fine. Section D will contain 3 questions. 3 questions will be there, and each of the questions will carry 5 marks. Each of the questions will carry 5 marks. So there will be 15 marks in total for your section D. So section D will start from question number 20 to question number 22. Okay, so 20, 21, 22. So 3 questions will be there for your section D. Okay, and over here, all the 3 questions will be having internal choice. Like suppose in question number 20, so there will be 2 parts. Okay, A and B. So you need to answer either A or B. Fine. Question number 21, there will be 2 parts, A or B. You need to answer either A or B. Okay, it is not like that there will be 5 or 6 questions and you need to answer any 3 of them. Okay, so that pattern is excluded from the ISC syllabus for physics. Over here you have internal choice. Okay, in these 3 sections, section 1, okay, not section A, section B, section C and section D. So in section B, section C and section D we will be having internal choice. 2 questions from section B, 2 questions from section C and 3 questions from section D will be having the internal choice. Okay, so these are all the sections, section A, section B, section C and section D. So 12 marks, 22 marks, 21 marks and 15 marks. So that counts to 70 marks for your theory. Okay, so one more important thing, that while reading or while going through your syllabus, be very careful not to exclude any chapter. as you can understand from here, all the questions are compulsory. If you exclude any chapter, suppose some chapter, one chapter or two chapter you are finding very difficult before exams to understand or to revise, and you are thinking of removing that chapter or excluding that chapter, and you think that going with the rest of the chapter you will miss out the questions. Okay, so do not remove or exclude any chapter. You have to read all the chapters very carefully. As you can see, all the questions are very compulsory in this pattern of question paper. All the questions you have to answer. Okay, and you never know which question will contain the internal choice. Okay, so you cannot remove any chapter from your syllabus. Okay, so that was all about the question pattern of physics for class 11. So that was all for today's video. I hope all of you have understood the question pattern, the mark distribution and the syllabus of physics for class 11. If you have any questions or if you want me to discuss any other topic, make sure you comment it down below. If you like the video, please give a like and make sure you subscribe my channel. Okay, so goodbye, take care, see you in the next video.